Greetings, M squared here. Today we are going to solve some equations using the angle addition postulate. So first we're going to just use numbers and then we'll move into a linear equation and a quadratic equation. Remember, if you're in my class, there's two separate videos. We did it all together in class, but we're going to do it two separate videos here. So if you need the segment addition postulate, hop over to that video. It should be on your assignment sheet. All right, we're starting with an angle that has this extra piece, an extra segment in it, splitting it into two different angles. We can tell they're not equal because right here there's two little arcs and right there there's one. So we know it's not a bisector. And here's our little formula. Remember how we say this. The measure of angle ABC, that's this one, plus the measure of angle DBC, that's this one, equals the measure of angle ABD. That's the whole thing. So basically it's telling you that the parts equal the whole. We're going to use that angle addition postulate that says if you add two parts, you get the whole to solve some problems. So the first thing I kind of like to do, instead of writing the formula down on this one, is I draw a picture of this little angle. So I do A, B, C, and D, and then I put in what they give me. So I say, oh, okay, ABC is 30, angle ABC. So I put a little 30 there, and CBD is 80, and they want me to find the whole angle. Well, if this little piece is 30 and this little piece is 80, then the whole thing, the measure of angle ABD, is going to be 110 degrees. You can write the formula if you want each time and then substitute. That's up to you. I like to draw the picture. So again, we're going to have another one. So it's just a really rough picture. A, B, D, and C, and it says ABD is 120. Now I can't put that in one of these little spots because it's actually talking about the entire angle. So what I usually do is I put an arc like that to show that I'm talking about the entire angle as being 120. And then I'm going to fill in this one, the DBC, that's this one right here, 70, and they're asking me for this little piece, ABC, angle ABC. Well, I can tell that if the whole thing's 120 and this is 70, then what I'm going to really have to do is subtract, right? So that's going to get me 50. So the measure of angle ABC is going to be 50 degrees, because in that case I had to subtract. So you want to be really careful on what parts they give you so you know whether to add or subtract. But you're probably going to do one of those. Okay, next we're going to start with a linear equation. Then we're going to move on to the quadratic. So we are going to make our little picture again. A, B, C, and D. And we're going to fill in what they give us. So ABD, which is the entire angle, is 100. DBC is 3x minus 7. And ABC is 4x plus 2. 4x plus 2. So I'm going to add the two smaller parts, and I'm going to set it equal to 100 because I know that if I add these two parts, I get the whole. So my equation is going to look like this. 4x plus 2 plus 3x minus 7 equals 100. Now when you get more familiar with this and it's easier, you could just combine the like terms here, 7x and the negative 5. But if not, write your equation and do it there. I know that I can combine x's. I can only combine like terms. Those aren't x's, those are numbers. I can't combine them with the 4x and the 3x. Those are different. So I'm going to have to add that 7x, and then I can combine these, 2 minus 7 is negative 5. And then I finish out with that 100. Remember, when you're solving a linear equation, you want to get the x's all alone on one side, so that means I need to move this 5. So I'm going to move the 5 to the other side. So I get 7x equals 105. And now to get x alone, I'm going to divide both sides by 7. 7 goes into 10 one time with 3 left over, and it goes into 35 5 times. So my x is 15. Did they ask me for x? No. I had to find x in order to find the measure of angle DBC, but I still have work to do. So I see that angle DBC is 3x minus 7. And I'm going to plug the x that I've just found in right there. So what is 3 times 15? Well, that would be 45 minus 7. So if I subtract there, I get 38 degrees. So the measure of angle DBC is 38 degrees. You could always check that too. You have a 15, you could plug the 15 in for the x's and make sure that those two quantities equal 100. I'm not going to take the time to do that, but it's always a good idea, especially if you're taking a quiz or a test. Okay, finally, we're going to use the the angle addition postulate to solve a quadratic equation. So same thing, my ABD, that's the whole thing. I'm not going to draw a picture right here. I'm just going to show you that that's the whole angle, right? Which means that I'm going to add these other two up to equal that whole angle. So the other two are 10x squared minus 5 and 10 minus 35x. So I've got some combining to do. So let's combine some like terms. These two are combinable. That's going to equal a 5. So I'm going to say 10x squared. At the same time, I'm going to scoot this 35x next to the x squared because I want it to get it in standard form. So I just simplified and put it in the correct form on the right side. There's nothing that I have to do to the left side because these are not like terms. So keep in mind, you can only combine things that are like terms. So in a quadratic equation, I need to get everything on one side. So I'm going to subtract 19 from both sides. And the reason I put it here is because it's like terms with the 5. I'm going to add 4x to both sides because and I put it here because it's like terms with the x. So I'm going to scoot over here because I know I've got to make some room. 10x squared minus 31x minus 14. My next goal is to find out the two factors that multiply together to get 10x squared minus 31x minus 14. So what I need to do is multiply my a and my c, make my little chart here. That's negative 140 x squared, and I want to see if I can find any factors that multiply to get negative 31x. Now those are kind of far apart. 31's kind of far apart, so I'm not going to start with 1, 2, 3. I'll just start with, let's see, I'll start with 10. 10 times 14. Let's see what I get there. So I know that the bigger one's going to have to be negative because of this guy right here. So 10 times 14 is going to add up to negative 4. Well, that's not good. Maybe I shouldn't have started so big. So let's go down to like 5 because I got a long way to go there. So 5 is going to go into there. Let's see, goes into 14 2 times with 4 left over, and it goes into there 28 times. So when I subtract those two, I get a negative 23. Well, it looks like I need to keep going farther down. 4, yes, 4 goes into both of those. So let's look. 4 and 35, I think. Yeah, that works. 4 times 35 is 140, but when I add these two, because this one's negative, I'm going to get a negative 31. So these are the factors I needed to make my box. We're going to use the box method for factoring. Remember, when you factor, the ax squared always goes here. That's this one. And the c always goes here. And then these two that we found, I'm going to put those in with my x. I didn't write the x each time, but I could have here. I just sometimes don't because I don't want to write it every time. But that's where it's coming from. Now, to factor using the box method, I find my factors by finding the greatest common factor in each row and column, and then that helps me find those two binomials. So the greatest common factor here is going to be negative 2, and here is going to be 5x. This is going to be 2x, and this is going to be, it looks like a negative 7. So these actually become my two factors. So I have 2x minus 7 for one factor, 5x minus 2 for the other factor. Something went wrong there. That's my mistake. That should have been a positive because then I get my 31. So sorry about that. So then this would have been a plus 2. Let's just double check. Yep, positive 4, negative 14. Okay, we're good. So 5x plus 2 is what we should have had there. So now I have to find out which x values actually make this whole expression 0. I need something times something to get 0, then one of these has to be 0. So what I actually do is find out what x value makes each one 0. I'm going to use a shortcut. Shortcut is take the opposite of that over that, just to save time. You could set each one equal to 0, subtract each time 5x equals negative 2, x equals negative 2/5. So here's our two x's. One's positive and one's negative. What I like to do, we haven't learned about negative x values, so we look up here and we see if they work. Well, if I put a negative in here, that's going to make this positive. And if I put a negative in here, that's also going to make it positive. So I think we're good. I think we can try both of those. So remember, I have to find angle DBC. So I'm going to have to plug 7/2 and -2/2 back into angle DBC. So which one's DBC? This one. All right, and I'm running out of room. So DBC is 10x squared minus 5. So first I'm going to try the 7/2. 7/2 squared is 49/4. I'm going to multiply that by 10 and then subtract 5. But I'm going to reduce this first. So that they're both even, so that means I can reduce by dividing both of those by 2. And I end up getting 5 times 49 over 2 minus 5. Because they're fractions, I'm going to make this with a denominator of 2 by multiplying 5 by 2, because 10 divided by 2 is 5. So 49 times 5, let's do that real quick. Whoops, times 5 is 45, 20, 245. But then I have to subtract 10, which will be 235. So one of my answers is going to be 235 divided by 2. The next answer, and you could use a calculator with this, I just don't happen to have mine. Oh, look at that, I do have mine, sorry. I didn't think I did. Well, hold on while I retrieve it, because it fell off my table. So I'll show you how to do this with a calculator now, and we're going to try that with -2/5. So in this type of calculator, it does have a fraction button. I'm going to show you how to use that. So I'm going to say 10. I'm going to put parentheses, and I'm going to say -2/5, because that's what my x is. I'm going to end my parenthesis and square it. And then it says -5. And what do we get? Let's see. I didn't use a negative. I used a minus. Let's try that again. All right, -3 2/5. And if I want to change that to an improper fraction, just hit that little key or multiply, and I find that it's -17/5. Now here's the problem with that answer, right? It's negative. At this level, we haven't learned about negative angles. Although that can happen, we haven't learned about it. So what we're going to do is we're going to just say, hey, although this is an answer x that actually works for that equation, it doesn't work for our angle problem. And a lot of times with quadratic equations, that will happen. One answer will work and one won't. So this is our final answer. And let's just make sure I'm right, because you never know with me and my math. Sometimes I get carried away and I forget things. So I'm going to do this again. 7/2, and I'm going to square it, -5. Let's see if I get the same answer. If not, we'll figure it out. Okay, 235 over 2. So that's our answer. And you could also, if you just did it decimal-wise, you could get 117.5 degrees like that. Either one works. So that was, I know that was a lot on that quadratic one, especially if it's been a while since you've solved quadratic equations. But good luck with that. M squared, signing out.